When is an exponential model appropriate? An exponential model may be used when a set of data show an overall trend of exponential growth or decline. The easiest way to identify this trend is by creating a scatter plot of the data. The pattern of the plot should be similar in form to the graphs of exponential functions we've previously seen. If you use a graphing calculator or graphing software, be careful about the scale of the graphing window. This can sometimes affect the appearance of the scatter plot. In this example, the table below summarizes sales amounts in millions of dollars by year for a particular company. Plot the data and determine whether an exponential function is an appropriate model. Let the x-axis represent the number of years since 2001. So we have a set of 7 data points representing sales amounts corresponding to specific years. Let's sketch a scatter plot using this data and see if an exponential model would be suitable for this situation. Our x-axis is our independent variable, and we're going to use it to represent the number of years since 2001. And therefore our y-axis will represent the sales amounts in millions of dollars. Our table of values has been reoriented so that we have room to draw our scatter plot. Remember that x represents the number of years since 2001, so let's add an additional column to the left of our table listing the x coordinates. So x equals 0 corresponds to 2001 because we are 0 years after 2001. 1 will correspond to 2002, and so forth. The y-coordinates for each of our points are given by the sales amounts. Now we can sketch our axes, and since all of our points are located on either the y-axis or the first quadrant, we will sketch just the axes in the first quadrant. We can use a scale of 1 on the x-axis, but we will need to use a larger scale for the tick marks on the y-axis. We will set the tick marks on the y-axis to represent increments of 1,000. Now let's plot each of the data points from our table. At 0, we have the point 0, 180. Then we have 1, 338. 2, 652. 3, 1250. 4, 2012. 5, 4100. And 6, 8651. The data clearly follows a pattern of exponential growth. Therefore, an exponential function seems to be an appropriate model here. Let's look at another example. Observations of the population of garter snakes in a particular field over a 1-year period are recorded in the table below. Once again, we want to see if an exponential function represents the appropriate model for a set of data. This time, our x-axis will represent the number of months since February, and our y-axis will represent the number of snakes observed in that corresponding month. Again, the table has been reoriented so we have more room to sketch our scatter plot. Let's begin by listing our x-coordinates for each point. X equals 0 corresponds to February. However, notice that we don't have a March. We went straight to April, so that corresponds to 2. And we've skipped months throughout, so we have 4, 6, 8, and 10. The y-coordinates for each of our data points will come from the garter snake population. Let's draw our coordinate axes. What scale should we use for the tick marks on the axes? Our largest value for x is 10, so we should be able to use a scale of 2 on our axes since all of our values are 2. And our largest y-coordinate value is 212, so we'll use a scale of 20 on the axes here. Now we plot our data points. For 0 we have 205, 2 we have 211, 212 for 4, 6 we have 197, 8 we have 181, and 190 for 10. Does this scatter plot seem to indicate an overall trend of exponential growth or decay? Based on these observations, it does not seem that an exponential function is an appropriate model. Perhaps some additional observation will be helpful in determining an appropriate model if there is one.